So in this lesson, we're going to discuss what happens to our parent function, our basic quadratic function of x squared, when we add c. Now notice this says edited because after I originally wrote it, I decided to add a couple things in, including this portion, finding zeros. Don't know why that's in a box though, of our function. Okay, now I'm going to try to do this all in one video because it's really not very long, but we'll see. We're going to graph quadratic functions of the form f of x equals ax squared plus c. So we already talked about in the previous video what a does. A causes our parabola to open up, open down. It can make our parabola narrower than the parent function, or it can make it wider than the parent function. Okay, now c is going to behave an awful lot like the y-intercept of a line. So I'm going to go over to my screen with Desmos, and we're going to look at this. The blue or purple line is my parent function, and the red line, so if I want the red line to look like the parent function, I have to make c equal to 0 and a equal to 1. See? That's my parent function. Now, what happens when I change c? So just like the y-intercept of a line, changing c just moves my parabola up or down. And in fancy terms, that's called a translation. All right? And then you'll see here that A makes your graph narrow, wide, turns it upside down, making it narrow or wide. Okay? So basically, C shifts your graph up or down. It's the y-intercept. Okay, and that's what all of this is going to say. What does plus c do to the parabola? Now notice it's always written in the form of plus c, but c isn't always going to be positive. So when c is positive, the graph moves up. So f of x equals x squared plus 7 would translate up 7 units. When c is less than 0, which is another way of saying negative, okay, so f of x equals x squared minus 7, it's a vertical translation. Vertical just means up and down. C units down. Now notice it doesn't say negative c, it's just the absolute value of c. So x squared minus 7 means this would translate down 7 units. That's supposed to be an n. Okay, now in this particular graph, our vertex isn't 0, 0 anymore, it's 0, c. Okay, so the vertex here would be 0, negative 7. The vertex on this one would be 0, 7, and our axis of symmetry is still x equals 0. And then one other thing to talk about is the domain and range. So domain, still all real numbers, but the range is going to change depending on where the vertex is. So here, this would be a parabola that opens up with the vertex at 0, negative 7. So my range is going to be based on, it's either going to be greater than c or it's going to be less than c, depending on what a is. In both of these, the range would be greater than negative 7, and the range would be greater than positive 7. Okay? All right, we're going to do a lot of graphing here. So in all of these, we have to compare the graph to f of x equals x squared. So over here, I already put in the points for y equals x squared because we talked about this on the previous video. So 0, 0, right 1, up 1, right 2, up 4. And then it's going to be exactly the same on the other side of the axis of symmetry. So this is my parent function, or my most generic general form of my parabola. Now what happens when I subtract 2? So I'm going to do 0 first because that's the easy one. So 0 squared minus 2 is going to give me negative 2. 1 squared minus 2 will give me negative 1. And 2 squared minus 2, that's 4 minus 2, which is 2. And then because I'm not moving left or right, there's still that symmetry to the y-axis. So that means negative 1 will also give me a negative 1, and negative 2 will also give me a positive 2. Now, just check. Let's look here. 4 minus 2 is 2. Yep. 1 minus 2 is negative 1. 0 minus 2 is negative 2. 1 minus 2 is negative 1. 4 minus 2 is 2. So when I subtract 2, my vertex goes from 0, 0 to 0, negative 2. So you see the y-coordinate changed, not the x-coordinate. The y-coordinate changed. Looking at another point, 2, 4 on the parent function translates to 2, 2. See, again, the x-coordinate didn't change, just the y-coordinate. So now when I graph in a different color, I'm going to graph y equals x squared minus 2. I'm going to do the positive side because that's just easier. So my vertex is now at 0, negative 2, 1, negative 1, 2, positive 2, and then because it's symmetric, all I have to do is, let's see, 1, 2, 1, 2. Okay. Now here comes the tricky part, describing it. And once we get out of this chapter and even next year, we won't need to use all the same terminology, but you need to get used to it. So in your homework, it'll be a drop-down menu, but comparing the graphs, well, they both open up, same axis of symmetry, which is x equals 0. The vertex of G is 0, negative 2, so that's different. That means it's a vertical translation 2 units down. Okay, now let's see if I can make that a little bigger. Okay, now I'm going to pause the video here and then I'll come back and I'll do the other pictures in part 2, or the rest of the notes in part 2.